Hello everyone. Consider this set of natural numbers 1, 2, 3, 4, 5 and so on. If someone asks you or if you're asked whether these natural numbers are an arithmetic progression, the only thing you have to check whether when they jump from one number to the other is the jump size same. What I mean is 2 from 1 is plus 1, 3 from 2 is plus 1 again. So if the jump size is the same, of course you add 1 to each number, you get the next number. So the difference between two consecutive numbers is always 1 here. So if this jump size is the same, then yes, it is an arithmetic progression. And let us consider these three numbers, just three numbers, 3, 5 and 7. Is this an arithmetic progression? The only thing you have to check is once again the jump size alone. See, 3 plus 2 is 5, 5 plus 2 is 7. So yes, this is also an arithmetic progression, no matter that they are just three numbers, whether they are finite numbers, just three, or they are infinite numbers like this. You just have to check the jump size, and if it is the same throughout, then yes, the numbers are an arithmetic progression. Now look at these numbers. Let me say it is minus 3, minus 6, minus 9, minus 12 and so on. Now here what is the jump size? Are they in arithmetic progression? If you observe, you see that you add minus 3 to each term. In arithmetic progression, you can call each one of it as a term. So the first term, if minus 3 is added, you get the second term. Minus 3 is added, you get the third term, which is minus 9. So yes, it is an arithmetic progression. And here the difference, this is popularly, the jump size is popularly called as the common difference. Difference, of course, we know why. Common, because it's common throughout the sequence. Of course, this is a sequence. A sequence which is in arithmetic progression is called a arithmetic sequence. We have seen many sequences in a couple of videos before. Now this one is a special sequence called the arithmetic sequence, where the jump size is the same. The sequence is called an arithmetic sequence if the jump sizes are same, or if there is a common difference between any two consecutive numbers. So coming back to this example, what we notice is the common difference need not be just 1, it can also be 2, it need not be just positive, it can also be negative. It need not just start with 1, it can start with any number, it can even start with a negative number. So our conclusion is the first term of the arithmetic progression can be any number. If you call it as A, actually it's popularly denoted by A. The first term is denoted by A in an arithmetic progression. A can take any real value. And what about this common difference? It's popularly denoted by D. D, the common difference or the jump size which we saw here, 1 plus 2 minus 3, can also take any real value, right? So if I say any real value, you may wonder, oh, can it be 0 also? Yes, of course, it can be. Suppose you have 5, 5, 5, 5. Is it an arithmetic progression? Yes, it is in arithmetic progression because the jump size here is 0. It is 0 throughout. So yes, it is an arithmetic progression. Now having seen all this, now let us try to generalize the whole thing. Now let me write a sequence generalizing everything. A1, the first term, A2, the second term, A3, the third term of the arithmetic progression, A4 and so on, right? So these denote the term, the first term, second term, third term, fourth term of an arithmetic progression, where let us assume that the common difference or the jump size to be D. D is the jump size, right? So now let us try to formulate something. A1, as I already said, can be denoted as A, isn't it? The first term can be written as A. Now what about the second term? Second term is A plus D, because we are given that D is the jump size and we are also given that this is an arithmetic progression, right? So the second term is a plus d. Now what about your third term? Third term is a2 plus d, right? a2 plus d, but a2 is already a plus d. So can I write the third term as a plus 2d? Yes, of course. I can write it as a plus 2d. If you do not understand, or if you find it too fast, just take your pen and paper and work out just this part. If you work out on your own, you will remember also better and you will understand with utmost clarity. Now, what is a4? a4 is a3 plus d, right? a3 plus d. So a4 is a3 plus d can also be written as, since a3 is a plus 2d, it can be written as a plus 3d. Now let me write it out clearly for you. a1 is a, or can I write it as a plus 0d, because 0d is 0, and a2 is a plus 1d, right? And a3 is a plus 2d. Look at the correlation here. The first term has a 0 here multiplied with d. The second term is 1 multiplied to the common difference. The third term is 2 multiplied to the common. It just decreases by 1. Look at a4 is equal to a plus 3d. See, it's decreased by 1. a4 is a plus 3d. Or can I call a plus 1d as a plus, since it's decreased by 1, 2 minus 1d. Or a plus 2d is 3 minus 1d, because we observed that it decreases by 1. a plus, what is 3d? 4 minus 1. 3 is 4 minus 1d. So can I generalize the whole thing? And bring it down to an is equal to a plus n minus 1d. Yes, isn't it? So we have arrived at a general form for the nth term, of an arithmetic progression. What is that general form? This one. an is equal to a plus n minus 1d. Now, what is the use of this general form? You may wonder, what if you give me a sequence and if you say it is an arithmetic progression? For example, if we are given 2, 4, 6, 8 and we are told that it's an arithmetic progression and we are asked to find the 15th term or the 20th term, can't I just find it? You may, but what if you are asked to find the 100th term or the 150th term? Then this comes in very handy for you. Now let us try to find the 15th term of this arithmetic progression. a15 is equal to a plus n minus 1d, or a is 2 and n is 15. So 15 minus 1, and d, which is the jump size, is plus 2. So into 2, right, which is 2 plus 14 multiplied by 2, or 2 plus 28. So the 15th term of this particular sequence is 30. Okay, so we have found it out using this general form of the nth term. But just that we should keep in mind that a can take any real value, which I have already told you. D also can take any real value, and even if the jump size or the common difference is negative, the D part will take care of it. This will take care of it. There is no alteration in this general form for the nth term. If it is negative, we are going to substitute a minus 3 here, and the sequence is going to reduce automatically. It would be a decreasing arithmetic progression automatically. Right, we don't have to worry about it at all. N will take values 1, 2, 3, 4 and so on, representing the term, the first or the second or the third term. Right, the position of the term is given by n. So I hope this is very clear to you. Thank you.